I'm Keith Light, Engineering Technical Leader at GE Critical Power, here with a three-part series on thermal derating to help you be sure you're choosing the right power module for your design application. System designers, our customers, must select power modules that can meet the performance requirements across the entire temperature range of the end application. But they must also take care not to select a power module which is oversized and therefore higher cost for the application. Thermal derating curves are the most common tool used to do this. Thermal derating curves show a module's allowable output current or output power under various airflows and ambient temperatures based on the temperatures of the module's components. Each point on a thermal derating curve represents a combination of output current or power and ambient temperature that causes the temperature of some components within the module to reach their operational limit. Thermal derating curves are used by our customers to select the optimum converter for the application or to help design the end application, including the cooling fans, heat sinks, and orientation of the DC to DC converter. For example, a particular application may require 25 amps in an environment up to 70 degrees C. Thermal derating curves can then be reviewed to select a converter and determine the required airflow orientation and if a heat sink is required to operate in this environment. In this example, the thermal derating curves show that this particular module can achieve about 23 amps at 70 degrees C and 200 LFM of airflow. If the customer prefers to have more margin, then the curves show that at 400 LFM, they can achieve about 28 amps at 70 degrees C. From this information, the customer can determine if this module will work in the application and design the appropriate cooling configuration to achieve the required output. At GE, each curve is generated by operating the module at a particular airflow and ambient temperature, then varying the output load until any of the components on the module reach their IPC derated operational temperature limit. For example, to generate a curve for 400 LFM airflow, the module is first operated at room temperature, 400 LFM, and the load is adjusted until any component reaches its IPC operational limit. This point is then plotted. The process is then repeated at 35 degrees C, 45 degrees C, 55 degrees C, etc., until the maximum allowable ambient is reached. The points that were plotted for each ambient are then connected together to generate a curve for particular airflow. This process is repeated at each airflow, including no airflow or natural convection. Please continue to part 2 of our series on thermal derating and design to learn about critical preparations for thermal testing. And please let us know if we can help you with selecting and testing the right power module for your application, or answer any questions for you.